So when we graph a polynomial function, we're just going to start sketching, but we're going to sketch some pretty accurate sketches, okay? They're not going to be exact, they're going to be close to being accurate. We know in behavior, we can do in behavior. We know how many increases and decreases we should have. We know about y-intercepts, because we've known about y-intercepts since we first started studying graphs in 9th grade, 8th grade, something like that. So now we're going to look at zeros, where it crosses the x-axis. Okay? That's the next thing we're going to look at. That's going to help us get a pretty good sketch of a polynomial function. So there is this theorem called the intermediate value theorem. Intermediate value theorem. Okay, in everyday English, it says if you have these two numbers on this interval, and you put them into a function, and this one is one sign, and this one is the other sign, then it's somewhere between those two numbers is a zero. Okay? For example, if you've got p of x, let's say p of a equals a positive number, and p of b equals a negative number, then there's a zero between a and b. Here's a, here's b. If I was drawing my graph and a was a positive answer, then by the time I got down to b, it's a negative answer. Then somewhere between a and b, I had to cross the x-axis to get from positive to negative. So somewhere between a and b, there's a zero. Okay? The intermediate value theorem doesn't help us find an exact zero, but it does help us prove that a zero exists, so we can start narrowing down our choices. Okay? Intermediate value theorem doesn't necessarily, it doesn't say, oh, well, it's a and 1/2 or whatever. No, it doesn't tell us that, but it does tell us that there's one between those two numbers, and that's what we need to focus on right there. Okay? So here's just an example. Let's say p of x, x cubed minus x minus 2. Verify that p of x has a real zero between 1 and 2. So you put 1 in, check the sign. Put 2 in, check the sign. If they have opposite signs, then you have a real zero between them. Okay? What's p of 1? What's p of 2? I did not get negative 4. I got 4. Alright, a negative, a positive. So there's a 0 between there somewhere. Okay? There's a 0 between there somewhere. Two is not the 0 because 2 gives you 4. How do we get what? Here, maybe the problem for x. No, p of 1 is 1 cubed minus 1 minus 2. P of 2 is 2 cubed minus 2 minus 2. Alright, okay. I don't know what the 0 is. I have no idea, okay? But I know if I graph this, there's a point at 1, negative 2, and there's a point at 2, 4, and the only way to get from one to the other is to cross the x-axis, right? So I don't know what it is, but I do know that it exists. Okay? Alright. So you need to know the intermediate value there, and we're going to come back to that a little bit later. We're going to start looking at real zeros. Dun, dun, dun. Lots of factoring and other stuff today. How many of you have graphic calculators? Get it. Get it out. Alright, I want you to graph this in your graphing calculator. If you don't have a graphing calculator, your neighbors can graph it on their graphing calculator, and then you can look at it. Give it a little look-see. You don't have a neighbor, and you don't have a calculator?
My neighbor does.
General sketch. Looks something like that? Yeah? Okay, sketch that. You might want to sketch that. You might need it for later. You might not. I don't know. Some of you can just help. Alright, erase that one. Graph that one. Alright, what does this one look like? Looks like a W. Anything specifically happening on any parts of this W? Bouncing off at one, so it comes through here, and it bounces and then goes up? Okay. Alright, good. Alright. Let's try this one. Let's just erase it. Try that one. I would have deleted it. Alright, what does it look like? It's odd. It looks like an N. So it's in here, and here, 2, 3, and here. But it looks like an N. Yeah, but general shape. It's got a few more lumps in there, right? It does drag at the 1. It does. If it's a little bit fatter at the 1, sort of flattens out some. Yeah. Okay. So when I have an odd power on this, bless you, what does it do at that 0? When there's an odd power, that's power 1, that's power 5, what happens at 1? It crosses over, right? Even power, what happens? Bounces off, yeah. Is that any even power or just two? Any even power. And just like this sort of flattened out when we got it up to the fifth power, the higher these go, it still bounces, but it gets flatter. It's a fatter curve at those points, okay? So you need to know if you have a multiplicity, okay, which this is a multiplicity when it happens more than once, okay, it's odd, it's going to cross and pass through it, okay. If it's even, it's going to bounce off of it, okay. So that's going to be a bounce, and it's going to cross. Alright, let's try to sketch graph. October 3 plus 6. Okay, so in behavior, general shape of this graph, what's this general shape going to be? Like this, yeah. That's what it's going to look like. What's the y-intercept? 0. Okay. How many extrema could I have possibly? I could have 2, or I could have 0 extrema. Okay. So that's what I can tell just from the way it looks right there. Now let's talk about the zeros, because that's where we really need to focus on our graphing. The zero. Is there anything I can factor out of all of that? Okay. This factor? What does that factor down to? How about x plus 3, x minus 1? Okay, so what are my zeros? -0, -3, and 1. Alright, with my zeros, it has to cross at those points. Where am I going to start it? Down here or up here? Down. It's positive, so I'm going to come up to here, go down, and go back up. It has 2 extrema. Right now, we're not going to find the value of the extrema. We will not be finding that right at this moment. But this is what we're going to be graphing this specifically today. You can find a y-intercept. I want you to hit that. This one, the y-intercept was a 0. Looks good. You've got to hit your zeros. That's how much I want you to graph. Alright, I'll give you one in factored form. I'll give you one that's already factored graph. How can you find your y-intercept if it's already factored? I'm sorry, I couldn't hear you. multiply your constants. Yeah, that's gonna tell you. Oh, and that, don't forget that. You got that sticking out right there. If you just multiply 3, 1, -1 with that negative right there, that would tell you your y-intercept without having to multiply the entire thing. Okay. In behavior, what's this one gonna look like? It goes up like this. Like this. Like this. Like this. So it starts high and ends low. It's gonna wave. Y-intercept 3. Okay. How many extrema? 2. Zeros? -3. Alright, let's see if we can bracket. -3, -1, 1, and I gotta hit that point. So it's gonna start up here. Okay. Open up. Alright, great. We do one more. How about this one? Alright, in behavior. General shape. Up, up. What degree is this polynomial? 4. It's a fourth degree. Wow, what's your y-intercept on this one? Yeah, that was really not nice. How many extrema could it possibly have? 3 or 1. This one has 3. What are your zeros? Alright, so 4, -2, 1, y-intercept -32. These are the points that I have to hit, right? Okay. Well, if I start this up here and hit all these points, that does not have the right end behavior, does it? No. It bounces, right. And how do you know it bounces? It's squared, right. See that? Even multiplicity. So it does start up and is that where it bounces? How do I know it doesn't bounce in? Right. It goes up, bounces, keeps going. Right. What's this point way down here that's actually like really way down here? What's that called? No, not that one. This one. Yes. What kind of minimum? Absolute minimum. What's this one called? Relative maximum. Why is that relative and not absolute? Right. See, here and here. this keeps going forever, forever,